Okay, so today we're going to be doing calculating complex numbers. And with these first examples here, I think it's going to look a lot like stuff you've seen before when you combining like terms and working with polynomials. So I have 7i plus 2i, and if this was like a 7a plus 2a, you'd get 9a. And so in this particular case, it's just 9i. So I'm just adding the coefficients here. On this one here, the only thing I'd be careful with something like this is when you have a minus on the outside. A lot of times kids will confuse that one, but it's actually pretty simple. You just remember it's a minus 1 out here. So if I rewrite this expression, it's 8i plus 3 minus 2i minus 1. And so I have an 8i and a 2i, which adds to 6i. And then I have a positive 3 and a minus 1, so that comes to positive 2. So this is 6i plus 2. This one here, if you guessed it's a negative 24i, you'd be right. That's all it is. You just multiply the coefficients. Okay, so this pretty much is how it works. These are the types of expressions you'll get with calculating complex numbers. But the one thing we have to be careful with, though, is the powers of I. Because if you've watched some of the other videos, you know I has a value. So it's not just like A, B, or C or something like that where the value can change. I actually has a value of the square root of -1. And that's how all of this started, is just with that value. That's how we got the complex number plane. That's how we kind of get rules that are a little bit different. But it all started with this value. So I squared is this times this, which is basically the same thing as saying I squared, and this 2 cancels out the square root symbol. So that's -1. Now I3, I to the third power, is basically I times I squared. And we know that I is the square root of -1, and we know I squared is a negative. So it's the opposite of the square root of -1. And I to the fourth power is I squared times I squared. We know I squared is -1. So that's -1 times -1, so that's just a 1. And so this gives us a pattern here. It starts with this one, the square root of -1, -1. The opposite of the square root of -1, and then +1. And I to the fifth power puts us back right here. And you could keep going with this, but it just kind of keeps repeating through these. Now this is a minus square root of -1. This is a minus -1. So what that is a positive 1. This is a minus I3, which we know is the opposite of that. And so the opposite of that is equal to this. And then I to the fourth power is 1, but it's the opposite of 1. So you can see that when you put a negative in front of this, it kind of changes things up a bit. But you have to be careful. So, I'll often suggest to students, it's a good idea to, whenever these come up, is to kind of lay them out like this so you can kind of see the pattern and you can follow the logic. Because a lot of times when you see them by themselves, you get kind of lost. You'll pick the wrong one or something like that. So if someone throws you a negative I to the fifth, you can always kind of go, well, I know what this is. So I know that's negative I to the 2, and then an I. And then you could always go, okay, I know this is a -1 and this is a -1. So those two together are like a positive 1. And then I know I is just negative, the square root of -1. So right now, that whole thing would be equal to this. And then it's the opposite of that. Okay, so just be careful with it. Now the one that comes up a lot, you'll see with this example right here. So I have -4 minus 7i times 3i, which would be 21i squared. Okay, we know I squared is equal to -1. So the truth is that, yeah, you'll get questions on things like this, but the thing that comes up the most practically is the I squared a lot. So you just have to remember that I squared is actually equal to -1, because that's going to change everything. You can see here I have -4. This is negative, and this is 21 times -1, so that makes it a -21. and then I have negative 4, and this would be plus 21. So then this is actually equal to 17. And that's what's interesting. Once you start multiplying these complex numbers, you end up getting just integers, non-complex numbers, because that expression there is actually equal to positive 17. Now, if we go to the bottom one here, you've got binomials. Now, you can use FOIL, but again, when I do binomials, I like to put them on these sort of generic rectangles or multiplication area models. So I have minus 7i plus 2, and I have 6i minus 3. So this would be negative 42i squared. This would be 12i. This would be 21i. And this would be negative 6. So this is negative 42. And remember, I squared is a negative 1. So negative 42 times negative 1 is 42. So I have a 42. And then I have a 12i and a 21i, which is a 33i. And then I have this minus 6. So then I'm going to do 42 minus 6, which is actually 36, plus 33i. So that's all there is to it. A lot of it's very familiar. The only thing you have to just be careful with is the powers of I, because the powers of I lead to a lot of negative positive mistakes when kids are doing this. The work's pretty simple, but it is fairly common to see careless mistakes with this, so just be careful when you're doing it.